When you hear the word water, what comes to mind? A glass of fresh water from the tap, or maybe a cup of tea or coffee. You may not think much about it, but the fact that we can turn water into steam to power ships and factories, or freeze it into ice to keep our food and medicines cold, is nothing short of a miracle. We are so familiar with the properties of water that we may not stop to appreciate how unusual they really are. It's hard to imagine anything alive existing without water, but there's still so much about this magical substance that we don't know. In the latest discovery, scientists unlocked some secrets about superheated water and found that water has an uncanny ability to defy its boiling point. The discovery was made by researchers from the Max Planck Institute for Dynamics and Self-Organization in Göttingen, Germany. Their findings were published on September 28, 2022 in the journal Nature. So how exactly did they do it? Well, through computer simulations. The team used a supercomputer to simulate millions of water molecules. They wanted to find out what happens when water vapor condenses at a temperature above its boiling point. And what they discovered was truly shocking. Normally, water boils at 100 degrees Celsius, or 212 degrees Fahrenheit. At this temperature, the vapor pressure of water is equal to the surrounding atmospheric pressure. When this happens, the water changes from a liquid to a gas. But in this experiment, the researchers kept the pressure at a constant level, even after the temperature went over 100 degrees Celsius. In other words, the water should have boiled, but it didn't. Instead, the simulation showed that the water molecules formed an amorphous solid. This is similar to glass. How is this possible? To understand what's going on, we need to take a closer look at the structure of water. Each molecule consists of 2 hydrogen atoms and 1 oxygen atom. They form a bent shape that resembles a pyramid. Now imagine millions of these molecules packed closely together. Normally, they move around easily, sliding past each other and forming hydrogen bonds. But when heated, they start moving faster. At 100 degrees Celsius, the molecules have enough energy to break their bonds and escape into the air as water vapor. However, if we increase the pressure, we make it harder for the molecules to break their bonds. Even if they gain enough energy to do so, the surrounding molecules will push them back down. As a result, the water can't boil. But something strange happens instead. The molecules slow down and lock into place, forming a rigid structure. This is called the supercooled liquid state. Here, the molecules are arranged in a regular pattern like a crystal, but they lack the long range order of a true crystalline material. Essentially, they're stuck in place but can still vibrate. This state is metastable, meaning it's relatively stable, but it can also be easily disturbed. For example, if a single molecule gains enough energy, it can break free and cause a chain reaction, causing the entire structure to collapse into a gas. This is why supercooled water is often described as a liquid. Glass is actually an ordinary liquid that has been cooled so quickly that its molecules haven't had time to arrange themselves into a regular pattern. That's why it looks like a solid, but it's really just a liquid in disguise. The same thing happens to water when it's superheated. But unlike glass, superheated water is more stable than regular water. That's because the molecules are locked in place and can't move around freely. This makes it harder for them to gain the activation energy required to break their bonds and turn into water vapor. In other words, superheated water has a higher boiling point than regular water. However, the difference isn't huge. In most cases, the boiling point of superheated water is only a few degrees higher than that of regular water. But why does this happen? Why does superheated water have a higher boiling point? This question has puzzled scientists for decades. Some believed it had to do with the hydrogen bonds between water molecules, but others argued that other forces were at play. The researchers behind the new study believe they've finally solved the mystery. According to them, the higher boiling point of superheated water is due to the molecules being compressed together. When water is compressed, the distance between molecules decreases, which strengthens the hydrogen bonds. This makes it harder for them to break free and turn into vapor. In other words, The key to understanding superheated water lies in the strength of its hydrogen bonds. The researchers were able to confirm this by looking at how water molecules vibrate. When hydrogen bonds are strong, molecules vibrate more slowly. This is because they have less energy to move around. In contrast, when bonds are weak, molecules vibrate more quickly. By measuring the vibrational frequency of water molecules, the researchers could calculate the strength of the hydrogen bonds. They found that superheated water has stronger bonds than regular water, which explains why it has a higher boiling point. But the discovery didn't end there. The researchers also found that the hydrogen bonds in superheated water are more evenly distributed. This means that the molecules are held together more tightly, making it harder for them to break free. This also helps to stabilize the supercooled liquid state. Overall, the new study has shed light on the mysterious properties of superheated water. By understanding how water molecules interact with each other, scientists are one step closer to unraveling the secrets of this vital substance. Who knows what other surprises await us? Maybe one day soon we'll be able to harness the power of superheated water to create new technologies that we never thought possible. Imagine a world where we could use water to store energy or transport heat more efficiently. The possibilities are truly endless. Speaking of water, let's take a moment to appreciate the importance of this humble substance. Water is essential for all life on Earth. It makes up over 70% of our bodies and plays a vital role in every process, from photosynthesis to cellular respiration. Without water, our planet would be a barren wasteland. Not only that, but water is also a powerful natural resource. It can be used to generate electricity, desalinate seawater to get fresh drinking water, and even transport goods and services. In fact, water is so important that many ancient civilizations were built along rivers and other bodies of water. However, despite its importance, water is often taken for granted. We turn on the tap and expect clean, fresh water to flow out every time. But the reality is that providing water to our homes and businesses is a complex and challenging process. It requires a network of pipes, pumps, and treatment facilities that are constantly under strain. Moreover, as the global population grows and climate change alters weather patterns, the demand for water is only going to increase. That's why it's important to understand the challenges associated with providing water and to appreciate the hard work that goes into ensuring that we have this vital resource. One of the biggest challenges facing water providers is aging infrastructure. Many of the pipes and pumps that deliver water to our homes were installed decades ago and are in desperate need of repair or replacement. This not only reduces the efficiency of the system, but also increases the risk of leaks and breaks. Another challenge is contamination. Water can be contaminated by a variety of sources, including agricultural runoff, industrial waste, and sewage. This can make the water unsafe to drink and can also damage the pipes and treatment facilities. To prevent contamination, water providers must implement strict monitoring and treatment protocols. Despite these challenges, water providers work tirelessly to ensure that we have the water we need. They invest in new technologies to improve efficiency and safety, and they educate the public about the importance of conserving water. In short, water is not something we should take for granted. It's a precious resource that we must protect and conserve. So the next time you turn on the tap, take a moment to appreciate the hard work that went into bringing you that simple pleasure. If you liked the video, don't forget to like and subscribe so you won't miss out on future updates. And thanks for watching.